Alright, welcome everyone to this final video here on Chapter 17. We're talking a little bit more about solubility. And in this video, we're going to talk a little bit about things that can affect and factor into the solubility of a salt or ion in solution. So let's consider this equilibrium reaction, CaF2 forming Ca2 plus 2F minus, right? And I can ask, right, how could I affect the solubility of CaF2, right? Let's say, how can I increase the solubility, right? And again, right, the idea of what is the solubility of CaF2, right? It's the amount of calcium fluoride I can put in solution to which it completely breaks apart, right? And so, right, I have an equilibrium reaction here, okay? So let's pretend I put in 5 grams of calcium fluoride in solution, right? 3 of those grams have broken apart, right? So the solubility would be like 3 grams per liter, right? So it's in a liter solution, right? Right, and the question is how can I get more of that 5 grams to break apart in solution, right? Now you can say, okay, increase the temperature, things like that, but let's not consider those factors, right? But instead, right, what would happen if somehow I reacted, say, that fluoride with something, right? When this calcium fluoride breaks apart, right, the fluoride forms in solution, right? Let's say I remove some of those fluoride ions by reacting it with something, right? Let's say I react it with an acid, right? Fluoride is a weak base, so if I react it with a strong acid, it's going to form hydrofluoric acid, right? And so that's going to remove some of those fluoride ions, right? Well, now I've removed some products in this equilibrium reaction, which is going to cause my equilibrium to shift to the right and form more calcium ions and fluoride ions in solution, right? Which means I will dissolve more of my solid, right? And so as I add acid to this solution of calcium fluoride, right, I'll be able to start dissolving more and more and more calcium fluoride in solution, okay? Right, and again, that you can add an acid or you can add something that again reacts with the calcium ions instead, right, to decrease that concentration. Right. And here's kind of a plot, right, of the solubility of calcium fluoride with respect to pH. Okay. Now let's say, how could I decrease the solubility of calcium fluoride, right? Well, it's now the exact kind of opposite way, right? Instead of removing fluoride or calcium ions, right? Now I want to add in calcium or fluoride ions, right? And this is that common ion effect, right? Right? So if I add some sort of calcium ion, some sort of fluoride ions, right? I've now added some common ion to this equilibrium reaction, right? So that common ion effect, right? Which is going to cause this equilibrium to shift to the left, right? Cause my equilibrium to shift to the left, right? And I'm going to form more solid, and the solid's going to become less soluble, right? If I tried to dissolve, right? If I tried to dissolve calcium fluoride in, right, a solution of, say, sodium fluoride, right? Well, I got a bunch of fluoride ions already floating around in solution, so I'm not going to want to form kind of more fluoride ions through the dissolution of this calcium fluoride, right? So this is going to cause this thing to dissolve a lot less in a solution that already has fluoride ions, right? Or calcium ions, okay? And this is, again, that common ion effect that we talked about in the previous video here on Chapter 17 as well. We're talking about acid to base equilibrium. Okay, works same thing here, solubility equilibria, right? When I add this common ion, it causes this percent ionization, this percent dissociation of my salt to be much less. Okay. One other thing that can affect the solubilities of salts in solution are when they potentially form complex ions. Okay, for example, silver chloride is a lot more soluble in a solution of ammonia because it can form this silver ammonium complex, okay, in solution, right? And that silver ammonium complex, right, then is removing some amount of silver, right? Because again, the equilibrium reaction that I care about is a silver chloride forming Ag plus Cl minus, right? Well, if some of that Ag plus gets removed, right, by reacting with NH3, okay, then I've removed some products, right, and I've now made this silver chloride more soluble in solution, okay? And so you can increase the solubility, right, again, following kind of this Le Chatelier's principle for the complex ion formations, right, which again is a Lewis acid-base reaction, okay, that forms these coordinate covalent compounds, okay, right, and again you have the central metal ion that gets surrounded by 4 to 6 ligands, right, typically in these complex ion formations, okay, right, and then finally, right, some salts, okay, can effectively be weak bases, right, themselves, right, magnesium hydroxide, aluminum hydroxide, right, these are actually kind of weak bases, and so these salts actually can affect the pH of solution, right, so these salts, it's very straightforward and very easy to see how the pH might affect the solubility of these salts, right, so in these salts, right, in the very acidic solutions, they become a lot more soluble, okay, because the acid will react with the hydroxide ions of the solution, right, and use them up, and so then you can just start dissolving more and more and more and more salt, okay, right. Now if I add OH minus ions, right, then I reduce the solubility of these things, right? Right. So, yeah. And so those are some of the different things that can affect the solubilities of salts, right? And again, it's typically through some sort of addition or removal of an ion that's related with the equilibrium reaction that we're concerned about, right? And this an application kind of the Le Chatelier's principle.